Alright, in this video, we are going to talk about the last one of the Simon 3.6 exponential. Now remember, when there is a picture, where's the answer? In the picture. The table value, it's also a picture. So smile, we got this. So blah, blah, blah. So we are given a exponential function. So using this table, we're going to answer some question. For example, what will be my N behavior? To the left, to the right, okay? And B, what will be the domain and the range? And C, what will be my horizontal asymptote? So in classroom, I mentioned about, imagine you're standing at 0. What will be my N behavior? To the left, so will be my left side. I'm going to look for that direction. What do you know about my X value to the left side? It's more and more negative. Very good. Now, what happened to my Y value? You know that my Y value gets more and more negative. So therefore, will be the M behavior to the left. Now, take a look at the right side. N behavior on the right side. As X gets more positive, okay, what happened? Do you see my Y value? You know that zone is still negative. Very good. But use the eagle eye. What do you know the number behave? You can say that zone. That is a perfect number. I see will be a -4, -4, -4. So this tells me eventually the -4 become the ending, right? So therefore, you know the end behavior tells me to the left, to the right. Done. All right, moving on. Remember what we talked about the domain and range? Domain, it's all about my X value. So what do you know about my X value? It's from -infinity to +infinity. Good. How about my Y value? Now remember, earlier we mentioned about eventually, right? So therefore, my Y value is from -infinity to -4. And that's it. Domain and range. Now in classroom, we say that, is there any horizontal asymptote? Yes, indeed. So this forbidden number, as you can see, y equal to -4, it's my horizontal asymptote. How do you know that? Because the trending, as my X gets more and more positive, I see the trending happening. So therefore, it's my horizontal asymptote. Good. Moving on. Part D. If A equal to -3/2, use the table value to find an equation. Now, find the equation for the function g of x. Now, do remember, we are given a style of the function. Okay, all we need to do just to pick a number, a coordinators, okay? So I said in classroom, I don't like big number. I do not like decimal, so what will be my best pick? I'm going to choose this point, -3, -16. So here we go. We are given a style of my equation. It is my g of my x function is equal to a times b to the x power plus c. What do we know about that? We know that given a is given to us, that is equal to -3/2. I do not know my b yet, so leave me alone. But do you know we are allowed to pick a point? I picked the point is -3, -16. So what do we talk about that? Plugging in, plugging in, plugging in. The -3 is my x value and the -16 is my y value. So that tells me I know that -16 is equal to -3/2 times b. What is my x value? A -3 and plus c. Now you may say that, oh, I recognize something even better. You know the c value is my horizontal asymptote. Yes, indeed. And what do we know about that? Horizontal asymptote is equal to -4. So now you can say that knowing this guy, I can simply just write -4 to here for my C value, horizontal asymptote. Ooh la la. So now, knowing this one, we're about to solve this equation. What do we want to solve? The B value is what we try to figure out. So undo everything. What do we say? We're going to both sides plus 4. So both sides plus 4, that cancel out. I got negative 12. It's equal to negative 3 over 2 times b to the negative 3 power. Very good. Eagle eye tells me both sides have the negative. I can drop it. Good. And you call that 2 is my denominator. Do not like it. Undo will times 2 on both sides. So 2 and 2 cancel out, but 2 times 12 become 24, and 24 is equal to 3 times b to the negative 3 power. Undo times 3, the opposite will be divided by 3. So therefore, I got a is equal to b to the negative 3 power. Now, we said my goal is to figure out what is my b value. So you may say that, so you know what? The negative power, I do not like that. So I'm going to rewrite this one as a fraction. So once I get the rewrite, I get a is equal to 1 over b to the power 3. Hey, I have an inspiration. The power 3 gives me a, I can rewrite as 2 to the power 3. Well, what do you know? Both sides have the power 3. We can just do what? Drop it. So now I have 2 is equal to 1 over b. Now remember, we said our goal is to solve for b. So what do we want to do? Undo. So b is my denominator. So I'm going to times b on both sides. So that tells me 2b is equal to 1. And what do we need to do? Both sides divide by 2. So b is equal to 1 over 2. Ooh la la. So remember, we would like to write the equation of this function as we know that the final answer should be an equation. So therefore, my final answer will be a function g of x that is equal to negative 3 over 2. And b is my base, 1/2 raised to the power to x minus 4. And this is what we mentioned about. We do not need a calculator, and this is the perfect answer. Good? All right, moving on. For the next one, they say that describe and analyze the behavior of the graph of this function. Now remember, we already figured out the function, so the function I'm going to rewrite here nicely. The function we get from part D, it is negative 3 over 2. Base is 1/2 raised to the power to x minus 4. And what do we know all about the base? What is my base? My base is 1/2. That is less than 1. So we know that it will be a decay. Good. And what do we know about the information? We say that because my leading coefficient is negative. So that tells me immediately that will be a negative direction. Good. Now we're going to look at the picture. What do we know? Now in classroom, I noticed some of you say that, what? So if that is a decay, how do I not see the picture? It's going down, right? So make sure, because the decay, okay, let's talk about the decay. Knowing the decay, my original graph should be like this, going down. Okay, but my leading coefficient is negative, so that tells me there is a flip. I'm going to flip over my horizontal asymptote. So if that horizontal asymptote, as you can see here, I'm going to use this one, it's even better. So here we go. The original graph was look like this. This was my original graph, okay? So this is my decay for sure, okay? Because my leading coefficient is negative. So that tells me I'm going to have a flip over my horizontal asymptote. So what you see, it's what you got. The horizontal asymptote, I'm going to flip that upside down. So now you see my picture. It's right here as the final answer. So therefore, seeing is believing. What do you notice about my picture? It will be increasing. And is that a U shape up or U shape down, aka the concave down? And That's what we talk about that. Good. And that's all for today. Thank you.